Hi everyone, Jamie Aliperti, Director of Solution Engineering over here at Opaque Systems. I'm going to show you a quick video on some of the security aspects of the Opaque platform. So Opaque's Confidential AI Platform is essentially a workspace that provides the infrastructure to run data analysis and AI workloads all while encrypted with verifiable privacy and sovereignty. So as I mentioned, historically you have data at rest encryption and in transit. Everyone's familiar with all these techniques, and our breakthrough innovation is essentially encrypted data in use. So that's encrypted data at runtime during computation. And the architecture consists of a few different components. Number one, you're connecting a data source. As you're connecting a data source, the data owner um, has the data encrypted locally, and they own the encryption key. The other thing that happens when they're connecting the data is they have a policy engine that they can set policies on how the data can be used. This could be a simple whitelist, it could be a more sophisticated um, set of rules that govern down to the row and column level what data can be used and how it can be used. The other thing that we provide on top of this confidential computing hardware is an opaque workflow engine. So after the data scientist essentially writes the job, either in our notebook interface, which is familiar to data scientists, where they can use Python, PySpark, and a lot of the familiar programming languages that data scientists like to use. There's also a no-code interface. And as the job is configured and essentially tested. It runs on test data. And then the test simulation then gets to be approved in an approval workflow by the data owners. So, not only do they set policies on how the data can be used, but they also can approve how the data is essentially being used on synthetic data, if you will. These use cases can be straightforward AI, more sophisticated analytics, or Gen AI type applications. Last thing you get with the application is the verifiable audit trail here in this green box. And that's signed by the CPU or GPU, the hardware that's essentially running the workload, that verifies that no one was able to see the data, not the data scientist, not Opaque, not the hyperscaler, not anyone who physically attacks the hardware. And these audit trails can be exported and verified with a number of open source tools. Last thing I'd like to highlight is a little bit more details on the connection process. So you connect an encrypted data source. The source is encrypted locally um, and transmitted into Opaque. The application also cryptographically attests the Opaque platform and establishes a secure TLS connection for communication. Then there's a confidential processing of data. The Opaque platform uses a hardware-based trusted execution environment made available with confidential computing hardware. This enables computation over data while encrypted. The data remains encrypted when in memory during computation. It's decrypted only within the CPU in the trusted execution environment and is re-encrypted when it exits the trusted execution environment. And the trusted execution environment also enforces any of the policies that I mentioned before, whether that be on the data or how the data can be used. Last thing you get is that verifiable audit trail that's cryptographically signed by the trusted execution environment, the CPU, providing tamper-proof traceability of the data and the user's actions that are very simple to verify with open source tools. So thank you very much. I hope this gives you a little bit of an idea of how Some of the aspects of security and governance are taken care of with the Opaque Confidential AI Platform.